In this video, we are going to talk about three very useful blocks in MATLAB Simulink, and those blocks are repeating sequence blocks under the sources. So in the sources, you will find the repeating sequence interpolated, and repeating sequence stair. So these three are really important blocks in MATLAB Simulink, and in this video we are going to compare each of them and we'll see how they give the output for the same inputs or for the same logic. So first of all, we'll add all of these three. Let's add to untitled MATLAB file. So we have added all these three. The first one is repeating sequence. Let's open it. The repeating sequence block is used to generate the repeating sequence of values. It takes a vector or matrix as input and outputs the value cyclically. This means that once the sequence is completed, it starts again from the beginning and repeat the same sequence. So this is what the purpose of this repeating sequence. Over here you can see there are two parameters. The first is time value, which is horizontal axis, and the second one is output values, which is the magnitude or vertical axis, or you can say y-axis. So here we'll define time. So let's say we are defining time like 0, then 0.2, and then 0.4, and output we want 0, 2 and 0. So kind of a triangular wave we are going to generate using this logic. So now let's close this thing, and now we are going to open the repeating sequence interpolated block. So let's open it. This is the repeating sequence interpolated block. This block is also generate a repeating sequence of values, but it interpolates between the values to provide a smooth transition. It takes a vector or a matrix as input, and instead of direct outputting the values, it interpolates between them using the different interpolation method like linear interpolation or spline interpolation. These interpolation can be useful when you need to create a smooth transition between discrete values. Just imagine that you have a set of data points plotted on a graph like this, but you want to determine the values at a specific location where you do not have any data point. So in that case, the interpolation helps you to approximate the missing values, and this can be done using the surrounding information of the data points available. So this is how it works. Now here also we have two inputs. This is the vector of output values and this is the vector of time values. So here in output values we give the same input as the previous one, 0, 2 and 0, and this one is for the time values, and we'll give the same time values as we have given into the previous one. So let's say it's 0.2 and then 0.4, right? Then we have lookup methods. Here we have total 4 lookup methods to generate the output, and this is our sample time. So after timestamp of every 0.01 second, it will interpret the values between the two data point. This is the repeating sequence interpolated. And now the third one is repeating sequence stair. Let's open it. The repeating sequence stair block generates a repeating staircase waveform. It takes a vector or a matrix as input, and the output is given in the form of stair steps pattern. It takes a vector or a matrix as input, and it will give output in the form of stair steps pattern. Each value in the input represents the height of a step, and the duration of each step is determined by the sample time of a block. You can use this type of block when you want to represent a staircase like a signal. For example, in digital control system or any event driven simulation. So here also we'll set the output values as 0, then 2 and then 0. So in all these three blocks we have set the value as 0 to 0, and timestamp is 0, 0.2, 0.4. Here also value is 0 to 0 and the time is 0, 0.2, 0.4, and here also 0, 2 and 0. Now we'll take a scope. First we'll discuss about this repeating sequence interpolated. In this block, first I'll tell you how the output changes when we change the lookup method. So for that, what we'll do, we'll take 4 blocks. In first block, we'll take it as interpolated. Then in second block, we'll use the use input to nearest. Then in third block, we'll use input below, and in fourth block we'll use input above. And now what we'll do, we'll just run it for 2 seconds. Let's run. Let me specify name over here so that we can identify it easily. So here you can see these are the 4 methods: interpolation, use AND values, nearest value, below and above. So you can see the result are different from each other, and based on this result you can choose whatever method you want to use. But this is what the difference created in output when you change the method. Now let's close this thing. We'll take another scope over here, and now we'll compare all these 3 repeating sequence block. First, in this case we have compared the lookup methods, and in this case we are going to compare 3 different repeating sequence block. The first one is repeating sequence block, the second one is repeating sequence interpolated, and the third one is repeating sequence stair block. So now let's run this simulation for 2 seconds, and let's see what is the difference in the output of each of these 3 block. So let me zoom it. So here you can see this yellow line is for repeating sequence, this blue step line is repeating sequence interpolated, and this step line, the red one, is repeating sequence stair. So that's how you can generate 3 varieties of waveform using the different blocks. So after comparing the output waveform of all these 3 blocks, you will be able to select the block as per your need, right, as per your requirement. When you simply want a repeating sequence type waveform, you can use this repeating sequence block. When you have a scattered data and you want to create a plot in between them, you want to interpret the data, in that case you can go for repeating sequence interpolation. Or whenever you want a stair step type of signals, in that case you can use the repeating sequence stair block.